possibilities are opening up for scientific cooperation between countries.
2-1-0. Liftoff. American precursor space as Discovery clears the tower.
Discovery, go and throttle up.
Discovery, roger, go for deploy.
Thanks to you and to everybody in the shuttle program. The crew is go for launch.
Roger, nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Good evening and welcome to the Johnson Space Center in Houston, Texas. I'm NASA's Sandra Jones. Thanks so much for joining us following the successful landing of the uncrewed Boeing CRS 100 Starliner vehicle as part of Operational Flight Test-2. Starliner launched from the Cape Canaveral Space Force Station just last week on Thursday, May 19th, and docked to the International Space Station just a day later on May 20th, completing a series of flight test objectives throughout the mission. Starliner undocked earlier today from the forward port of the Harmony module of the International Space Station and landed just a short time ago at the White Sands Space Harbor at the U.S. Army's White Sands Missile Range in New Mexico. That landing occurred at 5:49 p.m. Central. Joining us for tonight's briefing to provide comments after Starliner's landing and to address any questions are Steve Stich, manager of the Commercial Crew Program, Joel Montalbano, manager of the International Space Station Program, Suni Williams, NASA astronaut, and Mark Nappi, the vice president and program manager for Boeing, who will be joining us remotely today from the landing site. So we'll first start off with some initial remarks from each of our briefers before opening it up for questions. And we'll be taking questions on both our phone bridge as well as here in the room and on our social media platforms. If you're on the phone, please press *1 to add your name to the queue and ask a question. And if you're on social media, you can use the hashtag AskNASA to submit your question. So we'll now begin with some opening comments from Steve.
Yeah, thanks, Sandra. What an incredible day it was today. You know, we had the landing of Starliner today. It was a picture-perfect landing at the White Sands Space Harbor. Starliner hit another bullseye. I think the landing point was about 500 meters or so from where it was intended, just due to the winds being a little different than what was predicted. You know, it's great to have this incredible test flight behind us. The test flight was extremely successful. We met all the mission objectives. And of course, today was a big one with the undocking, the separation sequence, and then the deorbit burn, entry, and the landing. I'd like to congratulate the entire Boeing and NASA teams that have worked so hard on Starliner for many, many, many years. It really is a testament to these teams, to everybody who worked on it, their hard work, their perseverance, their dedication, working through various issues along the way and getting to this test flight today. You know, putting the vehicle through its paces on this flight is really the only way to prepare us for the crewed flight test. And the systems performed great on the vehicle. And, you know, once we work through all the data, we'll be ready to fly the crew on this vehicle. As you know, this is the second landing for a U.S. vehicle on land on the airbag system. And again, that system performed flawlessly today. The entire sequence of the day went beautifully. The undocking with the NASA docking system for the first time worked great. It was flawless. Starliner backed away and separated very cleanly from the space station. All those maneuvers were very nominal. Went to a position beneath the space station and phased out in front, and then got into position for the deorbit burn. We worked through a couple of things on the way out. We learned a little bit about calibrating the navigation system. It took us a little longer than expected. I think that was just learning by the team, going to a couple of different attitudes to get stars and to calibrate the navigation system. We also were able to hot fire the thrusters that had shut down earlier in the flight. We hot fired the 2 port OMAC thrusters, and those we did not recover. We saw an interesting signature that looked a little bit like the signatures we saw at shutdown. So maybe 25% or so of the thrust that we expected out of those thrusters, and so we'll have to go work on that after the flight. We did also hot fire the reaction control system thrusters. Remember, there were 2 of those that were deselected and shut down during the rendezvous sequence, and those worked fine. Those were available for the software. We checked out another 4 thrusters, and those worked really well. As I said, the whole SEP sequence went really well. The nav system performed well. The Vesta system took more navigation data backing away from the station, and that all worked great. We had a couple of things during the entry and landing. First of all, the deorbit burn was nominal. Put the vehicle on the perfect entry trajectory. The crew module and service module separated just as we expected. During entry, one of the navigation systems dropped the communication with the global positioning satellites a little bit for a period of time. This is not unexpected for a vehicle that goes through entry. The system came back and was tracking satellites just nominally. We did have one of the CM thrusters, the crew module thrusters, that looked like it might have shut down toward the end. It was really hard to tell when we transitioned from the use of the thrusters to the parachute sequence. It looked like one of those may have shut down. And then, of course, at landing itself, there was a bit of that detectors registered a little bit of hydrazine. So the teams backed away until they could get a good reading. Sometimes there's maybe a little bit of unburned propellant around. Sometimes those detectors can be a little finicky. It was about 5 parts per million. And then we saw no evidence of any leaks on the vehicle. The thruster pressures were all normal. The manifold pressures were normal. So this sometimes just happens. It happened with Space Shuttle as well. You know, when I just think back to the landing today, I mean, it was picture perfect. Beautiful to watch. All the parachutes worked just as expected. That forward heat shield came off right on time. We had 2 good drogue parachutes. We had 3 good main parachutes, and then a really soft landing. Landing was about 26 feet per second or so, which was very nominal. The airbags deployed just as they were expected to, and that whole sequence went perfectly. So I'm thrilled to be here today. It was a great day. We will learn from this flight, and we'll move forward, and looking forward to the crewed flight test very soon. And I'll turn it over to Joel.
Hey, thank you, Steve, and thank you again for joining us today. You know, just a few days ago, we were talking about an outstanding launch, rendezvous, and docking sequence. And today, I'm proud to congratulate the Boeing team, the Commercial Crew Program, International Space Station Program, and our international partners on just an outstanding undock and landing. And, you know, we talked that this was a landmark mission for everybody and for human spaceflight as we move forward. The vehicle was only docked for 5 days, but we kept a busy pace while docked. We were able to demonstrate the delivery of cargo. We delivered 500 pounds of cargo was delivered to the International Space Station. 600 pounds was returned from the International Space Station. We're able to do an inspection of the thermal protection system, which is critical for us to demonstrate for this mission, such that when we have humans on the vehicle, we send home a vehicle that's solid and ready for reentry. We did an audio checkout during the mission. We had the hatch open during the mission. We were able to test the different system compatibilities between the Starliner and the International Space Station. We also took a Space Station command and control laptop over to the Boeing Starliner and did some testing with that as well. All successful. So from our standpoint, just a huge success on this mission. You know, I'd like to say that to the Starliner and team, that we now have a cousin to Dragon and Soyuz that can safely deliver humans to space and safely return to Earth. So with that, a huge congratulations to everyone, and I'll hand it over to Suni.
Thanks, Joel. Wow, I'm just really psyched to be here. I mean, this team has just crossed the finish line on OFT2. It's pretty amazing. Of course, like Steve and Joel said, it was a flight test, and we learned a whole bunch of stuff from it that we're going to be able to incorporate into the crew flight test. I had the opportunity to talk to the crew on board while they were doing their activities. They just loved it. It had that new car smell as they got in it, you know, and they were just excited to be there and helping us work through the activities that they had to do for the International Space Station. I'm just really looking forward to this mission completion, and why I'm so excited about being here, because of course that paves the road for the crew flight test before too long, and we're going to have to kick out Rosie and Jeb and maybe take their place.
Thanks, Suni. And let's turn it over to Mark Nappi, who's joining us remotely from the landing site. Mark, are you there?
I am. Thank you very much. I'm really so happy for our team and very proud of them for the accomplishments that led to such a successful mission. We are extremely pleased with the results of this mission. I certainly want to thank ISS, the Commercial Crew Program, and all of our suppliers for such a successful mission. The mission went extremely well, like Steve said. All the phases from launch to orbital insertion, all the demonstrations that we did for the near and far field approaches through docking, all the docked and undocked work that we did, and then, of course, undocking into the reentry and landing today that you saw that was, like Steve said, picture perfect. We stood here on the white sands and watched it come down, and the team was just extremely excited and pleased with the results. OFT2, it was a test flight, and we expected to learn from this thing, and we did. We talked a lot about some of the previous anomalies that came up in previous conferences with the OMAC thrusters, the RCS thrusters, and the cooling. But the team handled those, the vehicle handled those extremely well, and it was a really good learning experience. The Starliner crew cabin remained around in the mid-70s, so it was a good environment for the crew next time that we fly. The Vesta system worked extremely well. It was just something to watch as it navigated itself to the International Space Station and then came in and docked. All of the operations that happened during docking with the hatch opening and the cargo destow and then packing all went extremely well. And, of course, the inspection that Joel talked about just a little bit ago was a good learning experience for us for future flights. So we are, again, extremely pleased with the results of this mission, and it just was topped off today with an incredible landing. All appears to be in really good shape. The team is working on the vehicle right now to get it secured so that we could get it moved to a staging area tomorrow and then start prepping it for shipment and be back to KSC around the 9th of June. And then we'll start preparing the vehicle for PCM1. And the team is extremely excited about this. Again, congratulations to the whole team. We couldn't be more pleased with the results and the great mission. So thank you, and back over to you, Sandra.
Great, thank you to all of our briefers for those initial remarks. We'll now open it up for questions. Again, if you are on our phone bridge, you can press *1 to submit a question. And once your name is called, please state to whom you'd like to direct your question. If you do find that your question has already been answered, press *2 to withdraw it. And on social media, use that hashtag AskNASA to submit your question. We'll start with a question from David Curl with the Discovery Channel. David, are you able to hear us? All right, we'll come back to him. Next up, we have Chris Davenport with the Washington Post.
Good evening and congratulations. I just want to be clear, I guess, for Mark or Steve. I mean, based on the objectives that you've accomplished with the mission, can you say now for sure, like 100%, that you're going to go proceed next with the crewed flight test? Or is it still too early and you want to see what the data looks like on the mission and on those OMACs specifically? Thanks.
I can start, and then we'll let Mark add his comments. When I look at what happened in the flight and the kind of things we'll need to work through over the next few months, I mean, I don't see any reason why we can't proceed toward the crewed flight test next. The vehicle performed really well. If I step back and look at this flight test, we met all the objectives. We went and looked at the performance of the vehicle, the flight software for one thing, from the point that Starliner separated from the launch vehicle all the way to landing performed extremely well. The comm system performed well. We have a few upgrades to that for the crewed flight test as well. We have a few things to work on between now and then, but I don't really see any showstoppers this time relative to last time, when we had challenges with the flight software and the comm systems. So I think we'll work through it, and we really do have the crewed flight test next on our focus. It's also nice that Mark mentioned talking about the post-certification mission, or we'll call it Starliner 1, because that's really the long-term objective, is to have these vehicles come up, carry a crew of 4, carry the powered payloads, and then stay docked to station for a 6-month increment. And I think now we're pivoting to the crewed flight test next, and then working our way toward that first post-certification mission.
And Mark, if you have anything to add, we'd love to hear it.
And that we're really pleased with the mission, all the objectives and the demonstrations being satisfied. The next step is to really now dig down into all the details and of the mission, with looking at all the instrumentation. So all of the subsystems will look at their subsystems in much more detail to make sure that we saw, or that we saw everything that we wanted to, and got the expected results. So after that, we'll have a lot more confidence in being able to turn the vehicle around for the next mission, as well as get into CFT. So planning for the end of this year, and as long as all those data reviews come out good, we put ourselves in a very good position.
Great. And our next question is from CBS News with Bill Harwood.
This is a question for Steve, I think. Every new vehicle has issues. I mean, things maybe you didn't expect, but they're within the boundaries, and this, that, and the other. How does this flight compare to Demo 1 in terms of expectations versus reality? And I'm not looking for a scorecard. I'm not trying to compare SpaceX and Boeing. I just want to get a general sense of how the Starliner did in that context. Now that it's got a full-up, flight to station under its belt. Thanks.
It's a good question. I hadn't had a chance to think a lot about that, but I would say the performance was very, very similar in lots of ways. We had a few minor challenges on this flight. We talked about the OMAC thrusters that have performed really well. We've hot fired on the ground numerous OMACs, so we have something to go look at there. We learned how to manage the cooling system, I think, on this flight. I think there was a lot of learning on how to manage things. When I step back and look at Demo 1, we had challenges between Demo 1 and Demo 2 that people may forget about. We had a major redesign of the propulsion system between Demo 1 and Demo 2. I don't see that here on what we saw on this flight. Between Demo 1 and Demo 2, we did a redesign of the parachute system on Dragon. Again, I don't see that here on Starliner relative to these parachutes. We've worked with Boeing and done numerous drop tests. The parachutes perform fine. So I don't really see, I think both flights, we learned a lot from both test flights, both the uncrewed test flights, whether it be Demo 1 or OFT 2. I think that learning may be a little different in different areas, but it's relatively the same. And then, we were able to move forward from Demo 1 into the Demo 2 test flight. And I think, given the data reviews that we'll have to do that Mark talked about, I think we're on track for that here with the crewed flight test.
And our next question comes from Stephen Clark with Spaceflight Now.
Thank you, and congratulations to you all. Just a quick question for Steve Stich. Could you clarify the number of RCS thrusters that you hot fired after undocking, and how many of those were actually recovered that you saw issues with earlier in the flight? That's a quick one. And then separately, the issue with the acceptance testing of the Dragon heat shield on the Crew 5 vehicle. NASA put out a statement earlier this week talking about about replacing that heat shield structure with a structure for a future mission. Was wondering how you go about clearing the heat shield structure on Crew 4, which is currently on orbit. Any concern with that? Has that been cleared of this manufacturing defect, or is that still under review? Thanks.
Yeah, good questions. I'll start with the questions relative to Starliner. So, we had 2 of the reaction control system thrusters that shut down, and the flight software fault detection took them out of the logic to be able to be fired earlier in the flight. Today, we hot fired those 2 thrusters, plus we even looked beyond that at some other thrusters, and we hot fired 4 more thrusters for a total of 6. And what we do is we put the vehicle into a free drift, so when a thruster fires, there's a corresponding rate on the vehicle, and that the navigation system measures that rate, and we can determine it with a thruster fire. And all 6 of those thrusters fired just fine, looked like they had nominal thrust, and we made them available for the flight control system. So we hot fired 6, and they were all good on the reaction control. Relative to Crew 5, both Starliner and Dragon have very complex composite parts, and so Dragon has a composite heat shield. And during manufacturing of the heat shield for Crew 5, we found a problem with the manufacturing, did some x-rays, and so we had to determine that heat shield wasn't a viable heat shield for Crew 5. So we moved up another heat shield in the flow, and we'll do the similar kind of x-rays and testing on that. We also take those heat shields and we put them through a battery of tests, and those tests actually apply physical loads to that heat shield, the kind of loads we'll see during the aerodynamic reentry sequence and also at the splashdown event. When the heat shield passes all those tests, and we can look at the measurements that we have instrumentation on that heat shield, when it passes all those tests, then we clear it for flight. So we'll go through that process for Crew 5 and clear the heat shield, and then we'll deem it good for flight. The heat shield on Crew 4, we went back and looked at the data. It does not have the same issues in manufacturing that we saw on Crew 5. It has been through this testing sequence where we go apply all the loads to it, and it has passed all those load cases, so we don't have any concerns with the heat shield on Crew 4.
Okay, great. And we do have a question here in the room. That will be from Eric Berger with Ars Technica.
Thank you, and congratulations on the mission and bringing it home today. It's a question for Steve, I think. Can you talk a little bit about the plan forward for the thrusters in terms of addressing the issues you saw both on day 1 and then the potential issue with the thruster on the crew module, I think you said, coming back today, where you said it may have failed right at the end. Is that the kind of thing where you're going to be able to look at data and sort of go with those basic designs? And you said you probably weren't going to need to redesign the system, but sort of what's the plan forward to dealing with those before you get to CFT? Thank you.
I think I'll take a crack at it, and then I'd like to hear Mark make some comments as well. So I think what we've got to do is we'll lay out kind of a fault tree. The one thing on the thruster that we saw really late during entry on the crew module is that vehicle will go back to the C3PF as Mark talked about. And so we can actually do some physical inspections and some more tests on that thruster and see if it performed as well. Did it really fail off? We can look at the data. On the other thrusters, I think we'll have to go build a fault tree, look at those fault trees, see what kind of data we have. Do we have any of their data during the flight we can look at, and then make a determination as what the next steps are. It could involve some offline testing as well for those ones on the service module, and then we'll see if Mark has anything to add.
It's about the same place I am. You know, the team has done quite a bit of work to try to put the fault tree together and look at the probable causes of the shutdowns that we saw, and none of them look to be serious that they would turn into some kind of design change. So we have more work to do. I agree. We probably need to be doing some offline testing to try to verify some of our probable causes, but I'm more optimistic that we'll be able to explain these and move on.
Our next question is from Jim McKenna with Aerospace Tech Review. Jim with Aerospace Tech Review, are you with us? Okay, we'll move on to Josh Dinner with Space.com. Josh, are you with us? All right, we'll try Marcia Smith with spacepolicyonline.com.
Well, thanks so much. Can you hear me?
We can hear you.
Okay, I'm wondering if you could just, maybe this is for Steve, could be for Mark. I'm just trying to understand all the different thrusters and the issues that have developed with them. So there are 12 RCS thrusters on the crew module, is that right? And 28 on the service module. and 20 OMACs. So which of those has had the problems on this flight? And the valve problem that you had back in August, are those the same thrusters? I'm getting a little confused with all the different thrusters here. And what are the commonalities amongst them? Are the RCS thrusters on the crew module pretty much the same as the ones on the service module, or are they entirely different systems?
Yeah, boy, now you're going to test my knowledge in numbers. Let's just, okay, so on the crew module, I believe there is 10 or 12, I forget the exact number, but those are used during the entry phase. Once the crew module separates from the service module provides all the propulsion during ascent, should an abort be required during ascent or during orbit. And during the rendezvous phase, the service module provides all the propulsion. It's also there to execute the deorbit burn, and then the crew module separates after the deorbit burn, and then it provides the attitude control all the way in space to the atmosphere and then all the way through. So we looked like maybe one of those thrusters shut down. Again, the data was a little sparse, so we'll have to go look at that. That thruster is a hydrazine-only thruster, so it is not a dual propellant thruster. The OMACs and the reaction control system thrusters on the service module are dual bipropellant thrusters, so they use monomethylhydrazine and nitrogen tetroxide as the oxidizer. And again, we recovered all the RCS thrusters that failed. All those are good. And then the 2 OMACs that failed, there's in each of the 4 doghouses, there's a total of 12 of those aft thrusters. And so during the flight, we fired 10 of those, and those all worked fine. For some reason, in the port doghouse, 2 of those shut down early, and so we'll have to go look at those. These thrusters are totally separate from the oxidizer isolation valves, the OMAC and RCS that we talked about, that we had the challenges with back from August. So those, think about, it's a way to isolate the thrusters that are on a line from the propellant tanks, and so that's what those thrusters are. That's what those valves are there for. So those all worked nominally through the whole flight. They were cycled several times, worked just fine. So those valves performed as expected. You know, and occasionally in Space Shuttle we would have a reaction control system thruster fail off as well. We'll just have to go try to build the fault tree as Mark talked about and understand what happened with the thrusters.
Thanks, Steve. Next up, we have Micah Maidenberg with the Wall Street Journal. Micah, can you hear us? All right, we'll move on to Jeff Faust with Space News.
Hi, this is Jeff Faust, Space News. Can you hear me?
We can hear you, Jeff.
Okay, great. Question probably for Mark Nappi. You know, when you tested the OMAC thrusters, the 2 that had failed earlier, and you mentioned you got an interesting signature and maybe 25% thrust, does that give you any clues about exactly what might be the cause of the failure? Does that help you winnow down the fault tree any further? Thank you.
Steve can maybe help me when I get to the more of the details, but because I was on the ground and of course we couldn't hear the results from the test that we ran. But I can answer the last piece of that. Is it certainly helps us understand some of the items on the fault tree, because this indicates that we had we had thruster failures, and this isolates it more to the thrusters themselves than any other part of the system.
I can add that what that helps you do is so that the thruster fired, so you know the flight software commands we're getting out. There's a device called an integration propulsion controller that then sends commands out to the valves on those particular thrusters, so we know that functioned fine. So we'll have to look at the legs of the fault tree where we got thrust, but it wasn't quite the level we expected. So we can kind of narrow down to what would those blocks of the fault tree be, and then what steps would we go take to remediate those.
Our next question is from Irene Klotz with Aviation Week.
congratulations. For Steve and probably also Mark, at this point, would you consider the oxidizer isolation valves something that would be an impediment for the crew flight test? And if so, how long do you think it would be to do a redesign of those valves? And then also just wanted to verify that if a redesign is decided on, that the costs for that are borne by Boeing, or might NASA be contributing to that? Thanks.
Yeah, I'll take a crack at it first, and then I'm sure Mark will have something to add. But relative to the valves, what we said when we brought this item to the joint Commercial Crew Program and Space Station Program Control Board, we would approve it for one flight, and we were going to, which was OFT2, and we were going to sit down after the flight and look at the data from that flight and then determine what the next step was for the crewed flight test. And so that's really the next step, is looking at all the data from the flight. Now, I can tell you that so far, the mitigations that we put in place for OFT2 looked very promising for CFT. Every time we cycled the valves pre-flight, whether it was in the C3PF where the vehicle is processed or at the pad, it worked as expected. There was no signature of any kind that showed we had a performance issue with any of those valves. I think Mark talked before that they are off looking at some options to redesign the valves. I'm not sure we have a timeline yet for when those redesigns would be in place, and I think they're looking long-term at redesigning the valve. So I think we need to look at the data again from the flight in a little more detail, but I think we might have a good path for the crewed flight test with the oxidizer valves. And I'll see what Mark has to add.
I agree, Steve. We've got a good system now. We know how to manage it in order to get to a safe place for launch. We have options for CFT. We still need to look at the longer-term solutions, and we've got several options in front of us. We have a good team working on it, and I feel confident that we can get an option in place for use on CFT and then look at the longer-term solutions for PCM1 and beyond.
Thank you. And our next question will come from Manuel Mazzani with Debate. Manuel, did you still have a question for us?
Yes, can you hear me?
Yep, we can hear you.
Okay. What is your level of relief, and of course for NASA, knowing that after this successful mission, we are basically on the verge of having two crew capsules capable of carrying astronauts to LEO? And another one for Mark. If you have to rate this mission from 1 to 10, what would be your rate? Thank you.
Yeah, from a commercial crew program perspective, we're just ecstatic with this orbit flight test. My favorite picture really was one that the robotics team took a few days ago of having Starliner docked at the forward port and Dragon docked at the zenith port. And then thinking about the crew doing comm checks between, I'm getting goosebumps a little bit talking about it, because between Starliner and Dragon, that's really what this commercial crew program has really been about all along, is having these two different companies with the great systems they've developed provide crew transportation to the space station under this new commercial crew model. And the flight that we have just landed today demonstrates that the Starliner is a great vehicle for crew transportation. And so it was just, I probably can't express into words what it meant to me and the team to have Starliner at station, to see the whole mission go well, to have that picture of the two vehicles there. It really is something I've been working on for the last 7 years of my career, and so it was just an incredible day for us. And I'll let Mark answer the second part of the question.
I think on a scale of 1 to 10, I think I'd give it a 15. This was incredible. We wanted to learn. We did. The team reacted to everything that was thrown at them perfectly. The vehicle reacted to changes like it was supposed to. The flight software worked in an excellent manner. We couldn't have asked for a better mission. It was truly a fantastic test play, and it really puts us in a great position to fly CFT.
Absolutely. Very special to see. Our next question comes from Jim Siegel with NASA Tech.
Well, thank you for taking my question, and congratulations to all of you and your teams. This is a question for Suni. To what extent are you and the other astronauts involved in the work that's done on this vehicle prior to its next flight? And are you going to be looking over everybody's shoulder there as they work on it?
We try not to do that. We just try to be an additive member of the team. Myself, Mike Fink, and Barry Wilmore have been working hand in hand with the Boeing team and the NASA operations team as we were getting this spacecraft ready to go to flight. And then as they were executing the flight, a couple of us even went over and did some of the sample stowage stuff for transferring the cargo from the International Space Station, working hand in hand again, like I mentioned, with the Boeing team. As this spacecraft comes home, I think we're a little bit hands-off. Let the experts take care of it. I think the three of us would definitely really like to get our hands on the next spacecraft, the crewed flight test vehicle, and work with the team. We still have a lot of work, like Joel and Steve mentioned. We learned a lot during this flight. Some of that learning will be applied to the CFT flight. We'll be working hand in hand with the Boeing engineers and the NASA folks who will be doing the operations, NASA Boeing team. And we'll be getting ready as best as we can. Hopefully we'll do a better job than Rosie and Jeb did. And we'll be ready to fly when the spacecraft's ready to fly.
Our next question is from Mark Carreau with Aviation Week.
Oh, thank you. I'm wondering how soon it might be before you can put a target date or a target period on the crew flight test, and also assign the crew members who would definitely fly.
Yeah, let me take this. I'll take the second part, and I'll let Mark take the first part. How's that? Since Mark and I are certainly a team. So relative to the crew assignments for the crewed flight test, we really need to look a little bit more about when that flight's going to fly, and then what the complement of the crew members being assigned to the flights around that, and then we'll make a decision. Hopefully here in the summer time frame, we'll have a decision relative to the CFT crew, and then I'll let Mark talk a little bit more about what that process will be to figuring out the crewed flight test date.
So there's a couple pieces to being able to set a flight date, and part of it is purely on us to get the vehicle turned around and get all the engineering products complete, and we're off working that right now. And of course, like I mentioned earlier, we need to finish off our data reviews to be able to solidify what needs to be done to this vehicle to get it complete. The other couple things that have to happen are, first of all, International Space Station has to have a place for us to go. So we'll have to play that one by ear until we can get a better understanding of their situation, as well as ULA being able to provide us a launch vehicle on the range. So all that has to come together in order to set a flight date, and we're probably several months from being able to do that.
We have a few more questions. The next one is from David Curl with Discovery Channel.
Can you hear me this time?
We can hear you.
Good. Excellent. Thank you very much. I'm a little confused, Steve Stich. No showstoppers, but there are questions to be resolved. Can you give us a better sense of that? And Suni, did Jell or Hines say anything to you specifically? I mean, you're very ingrained in this vehicle. Is there something that they said about the vehicle that you can give us specifically? Thank you.
Yeah, I would say every flight that we fly, and I have a lot of experience all the way back to Space Shuttle, there was always something that we needed to look at after the flight. Even after the 135th Space Shuttle flight, there were things to look at. So every single flight has things to resolve. It's been the same with every flight we've been flying with SpaceX. And so when I say I don't see any showstoppers, I mean, if you step back and look at what we were trying to do with this orbit flight test, it was really to see does the vehicle perform in every single phase of flight like we need it to, separating from the launch vehicle, doing the rendezvous burns, which we did not get a chance to execute last time, doing the navigation to the space station with the Vesta rendezvous system. That system performed flawlessly with all the sensors. We got great data on that. Testing the NASA docking system and docking to the space station, opening the hatch, and then establishing airflow between the two vehicles, looking at how the thermal environment was managed between the vehicles. How does the cooling work between Starliner and space station? How did the cooling work on Starliner in the transit time? And then, could Starliner do the functions we need to while it's docked to station, which, as Joel talked about, we went and took a laptop in and tested it. One of the requirements that we have is that Starliner would be a safe haven for a crew that's there for 6 months. If there's some reason they need to get in Starliner for a period of time and stay in Starliner, can they do that? And we tested some of those functions, including the audio between the station and Starliner. And then the undock sequence, and how did that work with the NASA docking system? How did the SEP sequence work? The things that we encountered in flight were really loss of redundancy in several thrusters. We needed to learn how to manage the cooling loops. We needed to learn how to manage a little bit of aligning the navigation system after we undocked today, which we did. And then if you look at the entry sequence, I mean, it went flawlessly, and that system has to work perfectly every time, including the landing system, the parachutes, the airbag system. We tested all those things. The cabin temperature was 70 degrees, 74 degrees, which is what we need for the crew. And so if I just look at overall performance of the vehicle, it was extremely good. What we do is then we go to the next level of detail, and our engineers between NASA and Boeing will do a detailed review, and we'll go look at the things that we saw, and we'll go see if we're really ready to go fly CFT. So.
And to answer the second question, Bob and Chell, they were really busy inside the spacecraft, so we were talking to them a lot about what they were doing and trying to get some feedback, just so now that we had that spacecraft in space, learning about how everything is set up and can we optimize it, can we make it better. So there was a lot of that conversation, but I think one of the coolest things that they said on the first day that we had the hatch open, they were like, do we have to leave yet? Because we haven't showed Samantha and Jessica it. We want to show them around and give them a little tour. And we were like, yeah, you got it. It's yours for right now, but you can't keep it. It's coming home.
It's coming home.
Thank you. And we do have a social media question for you as well, Suni. Sawyer on Twitter wants to know if you have plans to name the capsule now that it has landed.
Oh, that's not up to me. I was lucky enough to name the first capsule when I was out in the desert. But this one, I think that's other folks have other plans for it. So we'll see.
All right, we'll stay tuned. Our next question comes from Bill Harwood with CBS News.
Thanks very much. Two questions. I want to follow up on Irene's question about if there is a valve redesign. Is that on Boeing? Is it on Aerojet? Is it on NASA? I mean, how does that work? And following up on Stephen Clark's question, regarding the Crew 5 heat shield, did the failure manifest itself in a loads test specifically? In other words, was it a splashdown load sort of thing that caused the problem? And was the problem only seen in X-rays, or was there physical damage to the heat shield, like a crack, for example? Thanks.
Yeah, let's see. I'll take the heat shield question first. What happened for Crew 5 is when we put the heat shield through the landing loads case, it did not pass, and so we could tell there was some damage inside the heat shield from that test, and so we knew we couldn't go forward and fly that heat shield. In terms of the valve redesign, we'll work hand in hand with Boeing on any testing that's required. We have provided some testing that's a little bit special for the valves for this flight, but basically, I think Mark would be working that valve redesign out with his suppliers, and I'll let Mark address the rest of the questions.
Yeah, that's correct, Steve. We are working with the supplier on what's next for that valve. I would emphasize, though, that Steve and NASA has been very gracious with helping us with testing and certainly lending their expertise towards getting to the right solution so that we can come up with the right design. So they're giving us quite a bit of help.
Our next question is from Ken Kramer with Space Up Close.
Oh, hi, thank you, and congratulations on a great mission. I want to ask about the CFT, about the mission length. I think you guys previously had said about 2 weeks, and I'm wondering, that seems a little bit short. If you might make it a little bit longer, and if you Demo 2 was 2 months, for example, and if you do whatever length you make this mission, will it be crammed with science? Thank you.
Yeah, we have said a couple of weeks for the crewed flight test. We have the ability with that vehicle to have it fly up to 6 months. We have put that on contract with Boeing. We'll have to look at when it flies and what the time frame will be. You know, it's really going to be another test flight of putting Starliner through its paces, this time with the crew on board, and testing the displays and the life support system and those sorts of things. I'm sure we'll have objectives of testing. I talked about having a safe haven capability, or a capability to go close the hatch of Starliner and use that as a bit of a lifeboat if you need to get away from station for a little bit of time, or if there was a micrometeor impact that we had to put the crew in there for some period of time. So we'll do those kind of tests, and I suspect it will be a short flight, but we really have the capability. Boeing's built a great vehicle. If you just look at these vehicles, they really are the same config that will go fly for the longer PCM flights, and so it could stay longer if required.
And I'll add, you know, once we have the mission objectives set for the CFT mission, we'll make every use of the crew time and add science as required. And so I'd love to add science. We added a bunch of science you saw on the Axiom mission. So every time we get an opportunity with humans on board, we're adding science to those missions, and we'll do the same on the CFT.
Thank you both. Our next question is from Josh Dinner with Space.com.
Hi, thanks so much. My question is for Mark. It was reported recently that SpaceX is capping the production of its Crew Dragon capsule at 4. Has there been any number discussed at Boeing for the production of Starliner?
I'm sorry, can you repeat the question, please? You broke up.
Oh, I'm sorry. Yeah, so it was reported that SpaceX is capping the number of its Crew Dragon vehicles at 4. Has there been any discussion at Boeing for the number of Starliner vehicles to be produced?
Okay, so we have 2 Starliner crew modules that are available to us right now. And of course, we build the service module for each mission. So we need to really understand what the manifest is going to be for the future to determine if additional crew modules are required. But right now, we're at 2.
And we do have time for just a couple more questions. One of those will be from Marcia Smith with spacepolicyonline.com.
Thanks so much for giving me a chance for a second question. So the Aerospace Safety Advisory Panel, when they reviewed your program a couple weeks ago, they came back and they said that they urged NASA and Boeing not to rush to CFT. And certainly you've been saying this evening that you're not going to do that. But I'm just curious. You know, they talked about a concern about the staffing levels at Boeing, about the parachutes, and about just how difficult it is to go from an uncrewed to a crewed flight. So I guess for Steve and Mark, could you just talk about how you're feeling these days after the successful landing, about when CFT might happen? Are you still looking at by the end of the year? Or realistically, is it like into the first quarter of next year or the second quarter?
Yeah, I'll take the first part of it, and then we'll see. I'm sure Mark will have something to add. But yeah, right now Mark's getting the hardware ready, has been getting the hardware ready to go, and have that hardware ready by the end of this calendar year. And then I think what we'll do is look at the data from this flight and look at the rest of the things that we need to get done before the crewed flight test and look at where that flight needs to be. Certainly, it could move into the first quarter of next year. We've got to go work with Joel on the manifest and find the right time to go fly the flight. I think, we're on a good path now. I've been saying for quite some time to my team, and I really think the most important thing to make progress towards CFT was a successful OFT-2 test flight, and I think we had that over the last few days. I think we just got to look at the rest of the pieces. Suni and the crew will be extremely important. There's software updates with displays that Suni and the crew will be, and the astronaut corps will be testing. We've got to look at the suits, seats, and an ECLS test, likely in the summer timeframe with the vehicle, to make sure that we have all that right. So it's the next step really is to take the things that are hard to test without crew and make sure we're ready for those. And then we'll move that into CFT, and I'll see if Mark has anything to add.
Yeah, I think first of all, you hit the nail on the head. We are not going to rush into anything unsafely. We monitor our resources on a weekly basis to make sure that we're working the appropriate amount of hours and we're not pushing any discipline beyond their limits. Very accurate metrics to make sure that is the case. We have a schedule laid out that says we'll be able to complete the vehicle preparation for the end of the year, but we have to spend the next couple of weeks again going through all the data to make sure there's nothing that's applicable to CFT that we need to do differently. We also have to really nail down all the engineering products and put that schedule laid out so that it fits the vehicle being complete. So I think we just have a little bit of time in front of us to collect all this information and be able to put it into that schedule and make sure that we can support the schedule that we currently have laid out.
And our last question this evening will come from David Curl with the Discovery Channel.
Thank you very much, David Curley from Discovery. Steve Stich, I asked you after docking about the personality of the vehicle. So how about an update? Are you still with the patient? Do you have something else for us?
Oh, man. I would say this vehicle is determined. It was determined right out of the gate for this flight to go fly it successfully. It was determined to meet the flight test objectives, and it was determined to dock with the station even when it might have taken a little longer on my birthday to get there and make me wait a little longer for that present. It was determined today as we undocked and moved through the sequences back and away from the space station, and then all the way down through the atmosphere into landing. It was determined to go through its paces and to show that Starliner can do what's required to fly a cruise someday.
And thank you all to everyone who submitted questions today, and a big thanks to our briefers for taking the time to discuss the landing of Starliner. We do hope you'll continue to follow along with the Commercial Crew program at nasa.gov/commercialcrew. Thanks again for joining us. That will wrap up today's briefing.